So how about number 14? If you notice, we have something raised to the 1/4 power on the left. So if we were to raise both sides to the 4th power, it would make that go away. So if we did that, we would end up with 11x squared minus 18 is equal to x to the 4th. Now it almost looks quadratic, so I think what I'll do is subtract 11x squared and add 18 to both sides. So we're going to have x to the 4th minus 11x squared plus 18 is equal to 0. This looks like a quadratic equation, so we're going to say let u equal x squared. Then we'll end up with u squared minus 11u plus 18 equals 0. This will factor into u minus 2, 2 and 9, where they're both negative. So we'll have u minus 2 equals 0 and u minus 9 equals 0. When you solve them, you get u equals 2 and u equals 9. But remember, we don't want u, we want x. So we go back up to where we substituted it and resubstitute. So we have x squared equals 2 and x squared equals 9. To solve both of those, we need to do square root, don't forget plus or minus. So square root, don't forget plus or minus. So then, when we solve this, we get x is equal to plus or minus the square root of 2, and plus or minus the square root of 9 is 3. So let's go back and check all of those and make sure that they really do work. I'm going to pause the video and do that right now. So what I found out is that both negatives don't work. So x is simply the square root of 2 and 3. So how about number 15? This looks like another one of those quadratic-like functions. So we're going to let u equal x to the 1/3 power. If we do that, our equation becomes u squared minus u minus 6 equals 0. This will factor into u2, u3, where 3 is negative. And when you set both of those equal to 0, u plus 2 equals 0 and u minus 3 equals 0. You get u is equal to negative 2 and 3. And since we don't want u, we want x, we resubstitute. So x to the 1/3 equals negative 2, x to the 1/3 equals 3. Now to get rid of those 1/3 powers, we need to raise both sides to the 3rd power. When we do that, we get x is equal to negative 8 and x is equal to 27. Now I'm going to pause the video and just make sure that both of those really do work. And they do, so we're good to go to number 16. Number 16 is an absolute value equation. Remember, when you have absolute value, you have to set up your two situations. So you're going to have x squared minus x minus 4 equals 2, and then x squared minus x minus 4 equals negative 2. Solve them. So we're going to subtract 2 from both sides. X squared minus x minus 6 equals 0. Here we're going to have x squared minus x. When you add 2 to both sides, you end up with a negative 2 equals 0. And then factor. Remember, if it doesn't factor, then you have to use the quadratic formula. This will factor into 2 and negative 3. So then we set both of those equal to 0. And we get x is equal to negative 2 and positive 3. So there's 2 of them. And what about this one? This one will factor into x plus 1 and x minus 2. Set both of those equal to 0. And x minus 2 equals 0. So we'll have x equals negative 1 and x equals a positive 2. So again, I'm going to pause and make sure that all of these really do work. And they do. So how about number 17? We do have another absolute value equation. We need to set up our two situations. So x squared minus 6 is equal to 5x. And x squared minus 6 is equal to negative 5x. Move the 5x over, so we're going to have x squared minus 5x minus 6 equals 0. And on the other one, we're going to have x squared plus 5x minus 6 equals 0. So whenever we factor these, we're going to get factors of 6 that subtract to give us 5. That will be 1 and 6, where the 6 is negative. So we're going to find out that x is equal to negative 1 and positive 6. But how about this one? When we factor this one, we find out that we still have 1 and 6, but this time the 6 is positive instead of negative. So we end up with x is equal to 1 and negative 6. So we need to check all of these and make sure they work. I'm pretty sure some of them aren't going to work this time, so let me pause and find out. So what I found out is the two negative numbers don't work. So our solution is simply x equals 6 and 1. So how about number 18? This time we have two absolute values. We still have to set up our two situations. So the first one, a minus 1 equals 2a minus 3. It works just like the problem is. The second one, we make the right side negative. So we have a minus 1 is equal to negative of 2a minus 3. Okay, so that's the only difference. Solve it, so we're going to subtract this 2a from both sides. And we're going to add 1 to both sides. So we'll end up with negative a, then we'll have equals negative 3 plus 1 is going to be a negative 2. We divide by negative 1, so we get a is equal to 2. Over here we need to distribute the negative, so we're going to get a minus 1 is equal to negative 2a plus 3. We're going to add 2a to both sides. So that's going to be 3a minus 1 equals 3. We're going to add 1 to both sides. So we get 3a is equal to 4. Divide by 3, so a is equal to 4/3. You need to double check both of these as well and make sure they both work. They do both work, so our solutions are 2 and 4/3.